Hey Space Cadets, Neil deGrasse Tyson here, your personal astrophysicist ready to tackle a question that's been puzzling Earthlings for decades. Why are so many space photos, especially those iconic Apollo shots, seemingly devoid of stars? Did NASA stage a massive cover-up airbrushing out the cosmos to fool us all? Hold on to your telescopes, folks, because the truth, as always, lies in the fascinating realm of science. Get ready to explore the captivating interplay of light, cameras, and the vastness of space as we debunk this cosmic myth. You know, understanding the universe often starts with understanding the tools we use to observe it. Telescopes, for instance, have been our windows to the cosmos for centuries. From the early days of Galileo's rudimentary lenses to the sophisticated space telescopes orbiting Earth today, these instruments have revolutionized our view of the universe. And when it comes to capturing the cosmos, cameras are our trusty sidekicks. Whether mounted on a telescope or carried by astronauts, cameras help us document the wonders of space. They capture everything from the majestic rings of Saturn to the delicate dance of distant galaxies. But just like our own eyes, cameras have their limits. Our eyes and cameras both rely on light to create images, and both can struggle in extreme lighting conditions. The human eye, with its remarkable ability to adapt, still has its boundaries, and so do our cameras. Think about how your pupils work. In bright light, they constrict, letting in less light so you're not blinded. This automatic adjustment helps protect our vision and allows us to see clearly even in glaring sunlight. In the darkness, they dilate, trying to gather as much light as possible. This dilation is crucial for night vision, enabling us to see in low-light conditions, albeit with some limitations. Cameras work similarly, using something called exposure. Exposure determines how much light the camera sensor collects during a shot. Adjusting the exposure settings can make a huge difference in the quality of the images we capture, especially in challenging lighting conditions. Now, imagine an astronaut on the moon, bathed in the blinding glare of the sun reflecting off the lunar surface. The harsh light can be overwhelming, making it difficult to capture a clear image without proper exposure settings. To capture that astronaut clearly, the camera's exposure needs to be short and sweet, like a cosmic blink. A quick shutter speed ensures that the image isn't washed out by the intense sunlight, preserving the details of the scene. But here's the rub: stars, those distant suns, are incredibly faint compared to that lunar spotlight. Capturing their light requires a different approach, one that involves longer exposure times to gather enough light from these distant points. With a short exposure, the camera simply can't gather enough light from those distant stars to register them on the image. The stars appear faint, or might not show up at all, much like trying to see fireflies in the glare of a street lamp. It's like trying to hear a whisper in a rock concert. The signal is there, but it's drowned out by the overwhelming noise. To truly capture the faint whispers of the cosmos, we need to adjust our tools and techniques, ensuring that we can hear the delicate symphony of the stars. Now you might be thinking, but Neil, astronauts have eyes too. Did they see stars while bouncing around on the moon? And the answer, my friends, is a resounding sometimes. You see, our eyes are remarkable pieces of biological machinery constantly adjusting to different light levels. When astronauts were on the shadowed side of the moon, or inside their spacecraft with the lights dimmed, their eyes would adapt to the darkness, allowing them to see the starry backdrop. But out in the direct sunlight, like during those iconic moonwalks, their eyes, much like the cameras, would be overwhelmed by the intense lunar brightness. It's the same reason why we here on Earth have trouble spotting stars during the day. The sun's light scatters in our atmosphere, creating a luminous blue curtain that washes out the faint twinkle of distant stars. Chapter 3. Moon Landing Photos. Why no stars? Ah, the moon landing photos. A treasure trove of human achievement and unfortunately a breeding ground for conspiracy theories. These iconic images, capturing one of humanity's greatest accomplishments, have been scrutinized and dissected by skeptics for decades. Where are the stars? They cry, waving their skeptical fingers. The absence of stars in the lunar sky has fueled countless debates and wild theories. Some claim it's evidence of a hoax, while others suggest more outlandish explanations. But folks, it's time to put this one to rest. Let's delve into the science and common sense behind these photographs. The truth is far less sensational but infinitely more fascinating. The answer is elegantly simple and rooted in the fundamentals of photography. When taking a picture, especially in a setting as unique as the moon, several factors come into play. The camera settings, the lighting conditions, and the subject matter all influence the final image. Imagine you're an Apollo astronaut, standing on the moon's surface. The landscape around you is stark and otherworldly, with the Earth hanging in the sky above. The experience is surreal, but capturing it on film presents its own set of challenges. The sun is blazing, reflecting off the lunar dust and creating a brilliantly lit scene. This intense brightness is both a blessing and a curse for photography. While it illuminates the landscape beautifully, it also creates a high-contrast environment that can be tricky to capture accurately. To capture you and the lunar lander in all your glory, Mission Control back on Earth would instruct the camera to use a fast shutter speed and a small aperture, essentially telling the camera to take a quick snapshot to avoid overexposing the bright foreground. These settings are crucial for ensuring that the details of the astronauts and the lunar module are crisp and clear. And just like that, the faint light from distant stars, already struggling to compete with the lunar spotlight, is completely outmatched. The stars, though present, are simply too dim to be captured with the same settings used to photograph the brightly lit lunar surface. It's like trying to capture a firefly's glow in the middle of Times Square. The firefly's light is there, but it's lost in the overwhelming brilliance of its surroundings. The stars, much like the firefly, are outshone by the intense light of the lunar surface and the sun. The astronauts were focused on documenting their mission, capturing the equipment, the experiments, and their activities on the moon. The primary goal was to provide clear, detailed images of their work, not to photograph the stars. These historical photos serve as a testament to human ingenuity and exploration. They remind us of what we can achieve when we push the boundaries of what's possible. The absence of stars in these images doesn't diminish their significance. It simply reflects the technical limitations and priorities of the time. So, the next time someone questions the lack of stars in the moon landing photos, you can confidently explain the science behind it. The stars are there, just not visible in these particular images, and that's perfectly okay. Chapter 4. Long exposure photography in space. Now, if we want to capture those elusive stars, we need to change our approach. Enter long exposure photography, the secret weapon of astrophotographers and space telescopes like Hubble and the James Webb Space Telescope. Think of it like this. Imagine collecting raindrops in a bucket. A short exposure is like dipping the bucket in the rain for a split second. You'll get a few drops, but not much. Long exposure, on the other hand, is like leaving that bucket out in the rain for hours. Slowly but surely, those raindrops accumulate, filling the bucket to the brim. Space telescopes work on a similar principle. They stare at a patch of the cosmos for hours, even days, allowing the faint light from distant stars and galaxies to gradually accumulate on their sensitive detectors. The result? Mind-blowingly detailed images of celestial objects that would be invisible to the naked eye. Chapter 5. Space is bright and dark. It's a beautiful paradox, isn't it? Space, the final frontier, is both incredibly dark and dazzlingly bright. This duality is what makes space so fascinating and mysterious. Space, the final frontier, is both incredibly dark, a vacuum devoid of atmosphere to scatter light, and dazzlingly bright, filled with the light of billions upon billions of stars. The darkness of space is profound, an endless void that stretches beyond our comprehension. Yet, within this darkness, there are pockets of intense brightness. Stars, galaxies, and other celestial bodies emit light that travels across the cosmos, illuminating the vast expanse. These points of light are like beacons, guiding us through the darkness. Our cameras, much like our eyes, can only focus on a small slice of this dynamic range at any given time. The human eye is an incredible instrument, but it has its limitations. It can only perceive a fraction of the electromagnetic spectrum. Think of it like listening to an orchestra. An orchestra is a complex ensemble of different instruments, each contributing to the overall symphony. You can focus on the soaring melody of the violins, appreciating their high-pitched, delicate notes, or you can immerse yourself in the deep resonance of the cellos, feeling the vibrations of their rich, full-bodied sound. But you can't hear every single instrument with the same clarity all at once. Each instrument has its own unique sound, and our ears can only process so much at a time. Similarly, when we photograph space, we're choosing which part of this cosmic orchestra to highlight. The universe is a vast, complex symphony, and our cameras help us capture its beauty. Do we want to capture the brilliance of a nearby planet with its vibrant colors and intricate details? Or the subtle glow of a distant nebula, a cloud of gas and dust that holds the secrets of star formation? It's all about making choices, about understanding the limitations of our instruments and using them strategically. Our instruments, whether they are telescopes or cameras, have their own strengths and weaknesses. By understanding these, we can make informed decisions about what to capture, and using them strategically to unveil the wonders of the universe. Each photograph, each observation brings us one step closer to understanding the vast, mysterious cosmos we call home. Outro: keep looking up. So, the next time you see a space photo seemingly devoid of stars, don't cry foul. Remember, it's not a conspiracy, but a beautiful illustration of the challenges and triumphs of capturing the cosmos. Space is a tapestry of light and shadow, of the infinitely large and the infinitesimally small. And as we continue to explore its depths, we'll continue to refine our tools, our techniques, and our understanding, pushing the boundaries of what we thought was possible. Keep looking up, my friends, and never stop questioning, exploring, and marveling at the wonders of the universe.